And hello, we are live today. This is Mason coming to you from the slightly chilly Texas today. It is roughly 50 something degrees Fahrenheit here, which if you know anything about Texas, it's cold. So, um that's cold for Texas. It's not cold for most people in the world. Most people laugh at what Texas thinks cold is cold. But then I sit outside in the summer in 109-degree weather and I'm like, this is nice. This is cool. So, yeah. So it's good to be back with everyone. Just going to give it a little bit of time for people to join in and then we'll get started. How's everyone doing in the chat today? Hello, everyone. Hello, Tech, Akil, Amang, Muhammad, Saif, Zori. Nice to see everyone in the chat today. Hope everyone's having a great Wednesday. And hopefully we can do this. So let's go ahead and I'm gonna scoot over here. Actually, let's just move my camera a little bit. There we go. And let's get started. So welcome. Thank you everyone today for joining into another part of our security series. And today we're going to be talking about one of my favorite topics and one of the topics that I think is probably one of the more like underappreciated topics in systems administration and DevOps and security, and that is SSH. So for those of you that don't know me or haven't seen me present before, my name is Mason Egger and I'm a developer advocate at DigitalOcean. You can be on my website at mason.dev. Feel free to follow me on Twitter and to send me questions or see the kooky things I post on Twitter. You can see my website. Feel free to email me if you have any questions. If you want to watch me do live streams, I do live streams pretty regularly on Mondays and Wednesdays. I'm actually going to be doing one this afternoon. Some live coding at, I usually start around 4 p.m. Central Time. So probably going to be working on some Django REST framework stuff today. But yeah, that's me. The goals of this webinar today are I'm going to introduce you to SSH and OpenSSH, and those are not the same thing. We're going to talk about some commonly overlooked SSH security features, and also just like not only are they security features, but they're features in SSH. SSH itself is by nature a security tool in my mind. It's a connection tool, but it is a very powerful security tool. So features in SSH, I consider to just be part of security. We're going to demonstrate some useful SSH applications, like what some really cool things you can do with it, some feature things that you didn't know you could even start with it. And we're going to dive maybe a little too deep into some of the SSH arcane void and see what is going on with some of these features. So just a little bit of precursor. What is SSH? Well, SSH is a command that most of you have seen on your terminal, but that's actually not. It's not like the name of the package of the program. It stands for Secure Shell, and it's actually a protocol. And it's a protocol for creating encrypted communication channels between networked hosts, specifically between two networked hosts. It was created by Tatu Yildiz, I hope I said that right, in 1995 to replace some insecure login protocols such as Telnet, RSH, Login. I've played with Telnet a little bit. I've never seen RSH or rlogin personally. Those seem to probably be a little bit before my time. So because of that, because this protocol was created, one of the most popular implementations of the SSH protocol is OpenSSH. So this is a standard tool for remote management of Nix-like systems, so Unix and Linux-based systems. This does work, with things like FreeBSD, Unix-based systems, Mac, which is actually technically a Unix-based system, and even now, Windows supports OpenSSH. I can go into PowerShell and use SSH. So now it's not even just Nix systems. I guess maybe the way that they're doing it in Windows, it supports that now too. It's maintained by that's a typo, by the OpenSSH community, obviously, but actually it's maintained by the OpenBSD community. So the OpenBSD operating system is a very secure and hardened version of BSD, which if you're not aware of the BSDs, you should go look them up. They're pretty cool. And the OpenBSD community maintains the OpenSSH project. The first release was in 1999. There are two versions of OpenSSH. There is the OpenBSD version, which is where all of the active development happens. All of the development that actually happens on on BSD that happens for OpenSSH is in OpenBSD. And then there's portable OpenSSH. So portable OpenSSH is actually the version that most people, like say you're using SSH on Ubuntu, that's the version that you're actually using. The development happens in OpenBSD. They decide whether or not they want to keep these features, and then eventually, if the feature is good, they port it over to the OpenSSH version, to the portable version, and then there's actually a whole team that does this porting. So this all, like I said, all the development happens in OpenBSD and then is ported over to the OpenSSH, and it's held to the same very high security standards of the OpenBSD community. If anyone's ever actually, play with OpenBSD, I used to love OpenBSD. I've ran a couple of OpenBSD routers in my time. I've got a whole. If you go look for me on YouTube, there's actually back in like 2016, 2017, I did a whole series on BSD based things. I was always a big fan of the BSDs, so it's kind of how I've stumbled into OpenSSH, into the deep parts of OpenSSH. So, the pieces of OpenSSH, SSH servers. So there is the server, which basically is the part that listens for incoming network connections and then authenticates them and provides you a terminal. So if you want to access your machine remotely, you would stand up the server. I was trying to say terminal, the server, and you would run SSHD or the SSH daemon. There are the clients, which are used to connect to your remote device. So like whenever I open up my terminal and I type SSH, a remote server, then I'm SSHing in. That's me using the SSH client. There are many popular clients. Windows has PuTTY and native SSH now, as I was saying earlier, native OpenSSH. And Nix-like systems, there's SSH. There are a lot of other SSH clients. There's something called Mosh, which is a sort of, it's SSH, but it's not SSH. It's a mobile SSH console, mobile shell. I've looked like a little bit briefly into it, and it's kind of cool. But there's a lot of clients. But most people suffice with just the simple and the standard SSH client. There's two different protocol versions for SSH. So version 2 is the standard, and you should always use it. You should never touch it. Do not touch this setting. Version 1 is old. It's barely more secure than unencrypted telnet, and you may still find it on some like old embedded devices. Maybe you have some like old network equipment in your data center, or like an old router in your house, something. You may see SSH, version 1 there. But for the most part, you do not want to be using version 1 at all. It's not safe for you to be using. So that being said, we're going to do a quick little brief introduction into encryption so we can kind of talk about how SSH creates some of these connections, and also just, so that way if I use some of these phrases in this presentation, you're not overly confused. So for those of you, from the top level, this is basically a university cybersecurity course in one slide. So encryption transforms readable plaintext into unreadable ciphertext that people without the key cannot understand. So you take plain text, you take your thing, you encrypt it with ciphertext, and it creates a key. Decryption is the reverse of this process. A key is text. It can be numbers, letters, symbols, passphrases, can be a lot of things used to encrypt the messages. Keys are usually chosen by the user, which kind of like, some maybe, or sometimes, or more often than not, they're randomly generated. Like if you're doing a key gen with SSH, it's randomly generated. There are symmetric algorithms which are used that choose the same key for both encryption and decryption. Think back to when you were a kid and you played around with the substitute. Like, if I change A to B and B to C and C to D and I do all that, then no one will be able to read my thing, and that's basically a substitution cipher. It's actually called a Caesarian cipher or the Caesar cipher, because it's accredited to be claimed to be invented by Caesar. That's what all the books say. I don't really know if that's true. And that's basically your symmetric thing. And with that kind of encryption, you kind of have to protect, but you have to protect the key. Like the key is extremely important. You cannot let it become compromised, because it's both used for encryption and decryption. So compromise of one key is no good. Then there's asymmetric algorithms, which use a different key for encryption and decryption. This is something like RSA, where we have a public key and we have a private key. And what this kind of makes our encryption interesting, because I can take this public key and I can just throw it out to the world. The whole world can have it. And then whenever I need to get into something, I use my private key and I safely guard that private key. So if someone needs to send me an encrypted message, they can encrypt the message with my public key. and then only I will be able to read it, because the only way I can decrypt it is with my private key. So anyone in the world can send me an encrypted message, and only I will be able to read it. On the other side, I can verify myself because I have the private key for my public key, and only I will be able to like verify myself against my public key, which is exactly how SSH, RSA based SSH authentication works. I believe algorithms like DSA and other things use symmetric encryption. I will disclaimer: I'm not a cryptographer. I don't. Yeah, that's the beginning of that. So let's talk about SSH and generating keys. So, for the most part, whenever you're using SSH, some people use passwords. It's highly discouraged to use passwords whenever SSH keys are way more secure than passwords will ever be. So if we're going to generate a key, we're going to use the SSH Key Gen command. And this is kind of like the usage that comes from, like, if you were to just type the help command. And, SSH Key Gen, how many bits, comment, output file, the format, the type, DSA, ECDSA, ECDSA, SK, ED 25519, RSA, there's new passphrases and all of that. So by default, if I just ran SSH-Keygen, it's going to generate me a RSA 2048-bit key, which is kind of, it's still secure. It's still recommended by the OpenSSH community. However, I would say there are concerns about this particular, there's concern about RSA and if 2048 is actually secure and if people have cracked it. And as our computing power increases, as we get more and more computing power, the possibility of the large factoring of primes, which is what RSA is built on, it's large prime numbers, it becomes worrisome. So I personally use a 4096-bit RSA key. It's probably more recommended to use maybe an ECDSA key, which stands for elliptic curve digital standard something. So I think I'm about to go over what those are. But you want, if you're going to use RSA, use a big key value or use a newer algorithm. The only problem is RSA is pretty much accepted everywhere. It's got wide adoption. Even ECDSA has kind of gotten wider adoption now. But ED 25519 is still relatively new, and it works for some things, but I think I had a coworker of mine tell me that one didn't work on his YubiKey. So so there's a lot about that. And yeah, I'm kind of briefly watching the comments. I forgot to mention this. I will answer all of your questions at the end, and I usually start from the top down, but as I'm glancing over the comments, yes, cryptography is a big topic for another time, and I will 100% admit that I am not qualified to speak on that topic. I know enough about it to kind of get through it, and I in theory understand it, but cryptography is a very in my mind, it's a very challenging subject for me. It's a lot of math, and I'm not the biggest math person, but it's fascinating. I have a really good book recommendation. Remind me at the end, and I'll tell you which book it is. So which key is most secure? And honestly, as I was writing this talk, it depends on what time of the day you ask, because security moves so fast, crypto moves so fast, cryptography moves so fast, not cryptocurrency, cryptography, the study of encryptions and decryptions, and the study of secrecy is actually what it is. And it's so there are things that I've said that I've seen that the ECDSA key is good, and then I said, well, if the quantum computing bits come out in 2021, Google will be able to crack it, and it's oh my goodness. So we're just going to kind of go with what kind of the OpenSSH community recommends, and what a couple of my colleagues we discussed this. DSA is no longer recommended at all. It may still need it for legacy purposes, but DSA has been pretty much compromised, and most people do not recommend using DSA. RSA, in my opinion, is starting to show its age. We are concerned, a RSA key of 1024 bits is apparently not terribly difficult to crack with large machines. 2048, like I said, we're getting concerned about that. The fact that that's what SSH generates by default means that the OpenBSD community still thinks that it's secure, and in my mind, I trust the OpenBSD community, so I'm going to default to them on that decision. I personally use a 4096. I've heard of people using an 8.1 that 4096 multiplied by 2, 81981 something or another. I don't want to do the math right now. But yeah, RSA, in my opinion, I would put a guess that in the next 20 years, RSA, with the way that we're advancing in compute, RSA will be rendered useless, because unless you have keys of huge sites, because we're eventually going to get the compute power to do that. ECDSA is the new digital standard algorithm, standardized by the U.S. government. It's DSA, but with an elliptic curve. It's the elliptic curve digital standard algorithm. It's actually got smaller bit sizes. 521 is the max bit size you can use. And elliptic curve algorithms, this is where cryptography goes way over my head. But I've been told by people who know these things that it's a very good algorithm. As I was saying, ED25519 is a good algorithm, but it's not supported everywhere. So you might if you use it on your SSH service and it works, and that's all you need that key for, use it. Perfect. But it's still relatively new. It's still gaining support in the community. So a couple of quick SSH D security wins, secure SSH server wins that you can do to just get yourself a little bit, just to help you out. Usually found in Etsy SSH sshd_config. Disable root login. No one needs to log in via root. That's a no-no. Like sudo login and sudo in, so you can create an audit trail. Do not just allow blind root logins, unless, like, the only times that I ever use root logins is honestly whenever I'm prototyping so fast. Like I spin up a droplet and I'm gonna play with something really quick, and I plan on tearing it down within 3 to 4 hours or within the end of the day. Then I don't bother, because that server is not going to be like in production. But all of my production servers, nobody has direct root into access. They're direct root access. No password authentication. Use keys. Keys are the straightforward way to doing it. I will say that, like, it can be a little bit daunting, especially if you're brand new. There's great resources which I will be happy to point you to about this, but password auth, it's more likely that your password will be compromised unless you're using passphrases that are long, which I will admit I do, but those are on my keys. My keys actually have long passphrases on them, so just use keys. If you don't, you use what I'm reading the chat. We're getting there. The WIOT. Just hold on a minute. We'll get there. Disable X11 forwarding if you don't need it. So X11 forwarding is how you forward UIs to through SSH, so you can access like if you were running a GNOME or an XFCE or KDE environment. And SSH turns this on by default. If you're running a server and you're not running an environment, turn it off. This is just good security practice in general. If you're not using something, don't leave it on. That gives you that gives you an attack vector. Now, are there any opportunities for this? Not that I know of personally, but if one magically appeared or a 0-day appeared, and if a 0-day appeared and everybody who had X11 forwarding turned on was now vulnerable, by default that's everybody. But you're like, well, I'm using my servers, I don't use the UI. Well, you still have the forwarding turned on, so turn it off. So yeah, don't disable things you don't need. Okay, so those are just some really quick wins. So now we're going to talk a little bit about some of the things that we can do, that you should do when you're using SSH to be sure about this. And this is where we're kind of gonna I'm gonna switch back and forth between presentation, my terminal, and maybe something in my browser, depending on what we're doing. Okay, so when you first log into an SSH server, and let me actually .ssh known hosts should be the last one right here. Okay. So whenever I first log into a server, it normally, I thought I had deleted the thing. Let me try that again. /ssh/known host. There. That should hopefully be all the keys. Let's try that again. You're presented with this. Okay. So this is actually where a lot of people make I'm not gonna say make a mistake, but you're trusting too much. You're just like, oh well, yeah, this is right. Yes. And now you've logged in. And in reality, you could have just been compromised because of this. Someone could be spoofing this, and you need to my thing went well. Hopefully I didn't cut. I think I might have cut out there for a second. So anyway, yes, I think I am back. I'm going to keep going. Magic voice that doesn't become magic voice in the sky. Okay, good. I'm back. Thank you for the private chat. Okay, so anyways, what was I saying? Sorry, my internet cut out and my brain went whoosh. Oh, we're talking about SSH fingerprint. So if you didn't verify this, the likelihood is if you just stood up a droplet on DigitalOcean and you it was up for like 2 seconds and then you SSH'd in, the likelihood is you were not compromised. But you always should be behaving as if, bad things are happening. So in reality, what you should do is you should go into your console in the DigitalOcean console, log in, get the key, and verify it. So the only thing is, this is kind of a pain because you have to have a password off to be able to log into the console in the first place. So for the first time, I'm going to say, sometimes you got to take that risk. But for every other user that's logging into the server, say this is like a development server for my employees, and this is staying up for a long time, that actually becomes a little bit more risky. Like someone could try to impersonate the server and get me to SSH in and present my key and steal my key. So what you should do, and I need to pull up the command for this. Boop, there it is you need to keygen-lf. Okay. What you should do, SSH keygen, come on, -lf, and then Etsy SSH, you'll see all of your keys, all of your public keys. So by default on SSH presents the ECDSA key, and I think if I scroll back up, you can see the ECDSA key right here is SHA-256T, and we're T-perm. We're just going to say that's what that is, and then KHG at the end. So if I come here now and I SSH host my ECDSA key.pub, and I do SSH-keygen-lf to view the SHA, I should see TPIRM and then KHG. So I see that. I go back up here. I verify this. So this is what I'm doing as the administrator. But I can't expect all of my users to do this. They will not have access to these keys. So what you should do is say I'm in a big company and I have a development server that all my developers log into, or a deployment server or something. I should come in here, run that SSH keygen-lf on every key that's in here, and publish these fingerprints somewhere, and it should be part of my security policy. If you're going to log into a server, you must please verify that your key is valid, and here are the keys. That way, everyone in the company, maybe you have university servers. So I've actually never seen a company that does university server or that does work servers like this. But when I went to university, we had a handful of Linux servers that were very large machines that were for shared development. And for students to log in, again, verify these things. Verify that's actually the server that you think it is. Once it is, now you're safe, and you don't have to worry about people spoofing it. There are some companies that have huge that take this very seriously. One of my coworkers that I actually helped me with this talk yesterday was telling me about where he worked, and they would automatically do this and put it, I think he said, put it in LDAP, and they would make sure that it was safe. So just make sure that it is what you think it is. Verify the fingerprints match, and then automate the distribution of these fingerprints so that everyone who uses your servers can use them. But yes, the next one is what's called SSH agent forwarding. And so now we're going to look at, if we look at this diagram over here on the right, this is what I call it's actually one of my Terraform sample architectures. So there's a GitHub repository that has all the Terraform code that is needed to stand up this specific architecture. And this is kind of, in my mind, if I was building a small or medium business company and I was doing it with servers and not say like a PaaS, like our new app platform service, this is kind of how I would build it. There'd be load balance web servers that would be connected to the database as necessary. They'd be inside of a VPC. That's what this outer area is right here. And then all traffic would come in through a load balancer. It would distribute it. There'd be no access externally to these web servers, so I cannot get into them. And then I would jump in through a bastion, or what's known as a jump host. So the way that a bastion host works is you typically SSH in, and that basically kind of exists at the DMZ level, or that's what they call it, and then that is what allows you in. So that being said, that's where we're going to SSH into. But now I have the problem of how do I get my key? How do I get into these servers? Do I put a public key on this do I put one of my keys on this bastion and SSH into the web? So this is where I had a really cool conversation yesterday with a coworker. The answer to that is maybe. That might be how you want to do it. But if I'm doing this all with Terraform and I want to set this up, that's a little bit more difficult. I could use Cloud Init to do it. But what I could do is I could just put my SSH key on all of these servers and use ssh-agent to actually get through. So in this scenario, I don't want to have SSH keys on the Bastion. So then I can run ssh-agent on my machine to get local, and then I can use an SSH command to forward it in. So let's go back to my terminal. So one thing you'll see is I actually don't have to run ssh-agent right now, personally, myself, because I'm always running like in my ZSHRC file, I actually start ssh-agent every time. So ssh-agent basically keeps my what do they call my keys ready to go in memory, and then that in and of itself is a problem. We'll talk about that in a second. So what I can do now is, so if I were to SSH in directly into root at, okay, so this is I actually have that entire infrastructure stood up in my DigitalOcean cloud platform. So this is me getting into my Bastion. So if I SSH in directly into my Bastion, and so I happen to know that one of my web servers is at 192.168.32.5, and I am getting a response from that. So we're good there. Like I know I have a server there. If I actually just try to SSH in at 192.168.32.5, I'm going to get a permission denied. I don't have a key on this Bastion server. Those things only allow me in. I can't do that. So if I want to do it, since I have ssh-agent running, and it's literally just ssh-agent, I mean, I can just start another one. It's not going to hurt anything to see. So we have an ssh-agent running. If I run ssh-a root at bastion-minimal at my IP at my server, now I'm let in. But now if I actually want to try to ssh in 192.168.32.5, I can actually get in now because it forwarded my identity from my machine to the Bastion. And then now that key's there, I have that agent. Now it knows that's who I am. Now I can get into these. So this is one way of doing it. There are a lot of others. You can use like SSH proxies and OProxy commands. And the reason I mention those is because this does in some ways come with an implied risk. So ssh-agent keeps the key in memory while your session is active. So if I'm SSH'd in working on something and that Bastion host were to be compromised and someone got in at root, they could, in theory, pull my SSH key out of memory, and now they have my key. Now, there's a lot to be said about this. So it's like, well, do I not use this method? Well, it's all about risk assessment, and that's one of the things that you'll learn when you go through security and when you're working on your security stuff. It's all about risk assessment. In reality, if your Bastion is compromised, you have big problems already. So the likelihood is if the Bastion is compromised, other things is compromised. So this could be collateral damage. However, this could lead into another vulnerability. And if you do that, that could be an issue. If you don't think the Bastion's going to be compromised, or say maybe you respin up the Bastion, you could do. I've talked with people who sometimes spin up Bastions on demand when they need it. I SSH into these servers once every 3 to 4 months, and if I'm running a Bastion server, even if it's a $5 droplet, that's still $20 that I spent for something that I'm not using. Maybe I spin it up dynamically. I see someone in the comments talking about proxy jump. So there are a lot of solutions to this. I just wanted to focus on ssh-agent. But yes, proxy jump. I'll be honest, I don't know what proxy jump is. I know you can use like -o and then proxy commands, and you can do some like proxying stuff through there as well. I unfortunately didn't have time to get to that today, so this was just me talking about the SSH agent. But there are lots of ways to do it. The main thing here is take an assessment of your risk. If you're, a very high profile company that's worried about this kind of stuff, yeah, I would probably maybe implement slightly, more important things. If I'm a small to medium business and I just happen to be a moderately good tech guy, and it's unlikely that anyone's gonna compromise that Bastion host, then maybe it's not worth it. It's a risk assessment. You have to make the choice. And I see the answer was right here in the question and answers right here. Or in the comments. Security is always a trade-off versus user friendliness. It's a trade-off between usability and security, and it's always that way. The most secure computer on Earth is the computer that is unplugged and locked in a vault. but that is the most unusable computer on the face of the planet. Now, the most usable computer on the face of the planet is one that has no passwords. You can just do whatever you want. And we have to find the area in the middle there. And it's a risk assessment that you yourself have to do. So yeah, ssh-agent. Personally, I would use it, and then I would just secure my Bastion server. One way to maybe secure my Bastion server is I actually love making my Bastions free BSD. DigitalOcean actually has a free BSD droplet. Most of the time, it's actually really funny, and we're going to talk about honeypots in a little bit. Most of the time, whenever people try to attack a free BSD server, and if they ever actually get in, they have no idea how to do anything because most people aren't used to training on BSD servers. So yeah, it's pretty interesting for that. So my Bastions are always BSD servers. What did I click? Okay, here is one that we're going to do, and this one's actually probably, I would say, in my opinion, one of the more complicated. Man, I'm getting a lot of Slack messages. One of the more complicated examples in this presentation. So, two-factor authentication with SSH and PAM using Google Authenticator. So someone was trying to, like, are we going to use this? Yes, I'm totally getting there. Okay, I keep clicking on the magic link that's going to show up right there. PAM are pluggable authentication modules, and it's basically a way of writing your own custom authentication stuff. More often than not, I'm going to close Slack real quick because I don't want to keep listening to that. Go away, please. Sorry. I keep getting the little claves in my ears, and it was bugging me. So, PAM is a pluggable authentication module that allows you to do your own custom authentication. I'm not going to do much about PAM today, but maybe one day I'll do a PAM talk. PAM is something that most people avoid because they think it's complicated. And in reality, it's actually not as bad as people think it is. It's just you have to know how to do it. And I have a book on PAM that is amazing, that I would highly recommend to anyone. So let's hope this one works, because I was having a little bit of problems with this morning, because this is, as I said, this one takes a little bit of setup. Let's go ahead and do some PAM. Not PAM. Let's do some two-factor auth. So we're going to SSH in as root at 2fa.aggr.codes. So the only thing I've done so far on this particular server is I've installed libpam-google-authenticator because I didn't want to have to waste time in my tutorial installing it. In my slides, which will be available, there is a link to the exact tutorial that I'm about to use to kind of walk us through this. So I have the Google Authenticator open or installed. So now all I have to really run is Google Authenticator. Do I want my tokens to be based on time? Yes. And now it gives me a large thing that it's always so large I can never actually use it. And the sad thing is that I need Slack. I'm going to send, instead of trying to type that into myself, I'm going to copy and send that to myself. Yes, I'm getting messages. Thank you. I'm going to send this to myself so I can add it to my own personal. Then I'm going to close Slack again because I still don't want to listen to all of that. Okay. And whoop, there we go. So now I've sent that little message to myself, and I'm going to pick it out of here. I'm going to add it to my Google Authenticator. So if you just give me 1 second while I do this, remove that account, copy that text. And sorry, I can't share this with you, but unfortunately have all of my Google Auths in here, so I'm not going to be able to show it to you. So I paste it in and I add it, and now I have it set up in my phone. So now if I go ahead and say, do I want to update my root Google Authenticator? Yes. Do I want to disallow multiple uses of the token? This restricts you to one login every 30 seconds, but it increases your chances to notice or even prevent man. Yes, the token should only be allowed to be able to use once. This will slow down a lot of attacks. So by default, a new token is generated every 30 seconds. In order to compensate for time skew, the thing allows you to have multiple. So if you've ever used a two-factor auth token and you just barely get it in, like you type it in and then it changes, and it still works, it's because it uses this kind of time skew. So, but this one's basically saying, do I want to extend that to a 4-minute period where there's 17 codes? The answer to that for me, no. If your time is skewing a lot and you need to do that, you can always come back and change this later. But personally for me, I ain't doing that. That's just increasing the attack vector window. If the computer that you're logging into isn't hardened against brutal, you can enable log. Yeah, we're going to enable rate limiting essentially. So that's all the stuff we have to do to set up for the Google Authenticator. Now what I have to do is I have to actually set up all of the other stuff, which is fun. So what we're going to do is we're going to go ahead and just open up etc pam.d sshd. And what I'm going to do is I'm going to go to the bottom. I'm going to add the following lines. Auth required PAM Google Authenticator .so null OK. So the reason so basically this is saying I'm requiring the Google Authenticator SO, and null OK means if I haven't set up a two-factor auth token yet, then I'm still allowed to log in. If you don't have this and you haven't set one up yet, that person can't get in. So that's what the null OK is here for here. Honestly, what I would excuse me. And then we're going to add auth required PAM permit.so. And basically, this is required to allow authentication if a user doesn't use an MFA token to log in. So when logging in, each method needs a success to allow authentication. If a user doesn't use the MFA auth tool, utilizing the null OK option returns an ignore from the interactive keyboard authentication PAM permit.so, then returns success and allows the authentication user to proceed. So if we save and close that file, and then let's go ahead and open up etc SSH D configs. This is our SSH server config settings, and we're just going to look for challenge response authentication. And basically, this is saying, do you want to actually use some PAM modules with this, and allow challenge responses, which will allow us to do our two-factor auth. It's usually set to no. We're going to set this to yes, and then what we're going to do is we're going to go ahead and open up a second terminal. Whenever you're doing this stuff, always open up a second terminal before you try to actually do it. So I'm going to try to log in real quick. And because I'm using a SSH key, I'm going to automatically be allowed in. Oh, I didn't restart my service. Systemctl restart SSHD. Again, because I'm using an SSH key, it automatically bypasses that. So if this is using password auth, you actually would be okay with this. But because we're not, the SSH key automatically bypasses it. But what if I actually want to do two-factor auth whenever I'm using this, whenever I'm using a key? So let's just log out of that again, and let's go ahead and fix that. So what we want to do now is we want to go ahead and open up our etc sshd config again. And at the very bottom, we're going to add authentication. Okay, you know what? I'm going to copy and paste this because I can already tell I'm not going to make it work. Let's copy. That didn't work. Come on. Copy, paste. So public key password and then public key keyboard interactive. So by adding these authentication methods, I will now be able to actually SSH key to either a password. Basically, SSH now can either use a password or a verification code to enter, or all three, as it says, as the tutorial is saying. And then we're going to once again open up our etc pam.d sshd. And what we're going to look for is we're going to look for include common auth, and we're actually going to comment this out. This tells PAM not to prompt for a password. So we're not going to have the ability to use passwords with this. So again, I restart my SSHD service, SSHD, and I try to log in over here. I think this is it. And now I get my verification code. So now I'm actually, so it accepted my key. And now we have, now I come over here to my, and it worked. So with that tutorial, I've now been able to enable two-factor auth. We can also use this to enable something such as you can do two-factor auth whenever you're sudoing. So every time you sudo, again, this is where usability versus security comes in. If you're using sudo a lot, that could be very annoying. If you're someone that doesn't sudo very often at all or shouldn't have that ability that much, like having that auth is a good thing. Again, you have to make these assessments. I see in the comments anyway, to use YubiKey instead of Google Auth. I actually don't know. I've never tried it. I'd love to know the answer to that because I know people would probably be interested in that. So that is two-factor auth with SSH. This is the exact community tutorial that I literally just worked through very quickly to demonstrate this. There's a lot more in this tutorial. whenever I send out my slides, you'll be able to have access to this. You'll be able to get access to the slides after this presentation. Port forwarding. Port forwarding is a very fun and very awesome part of SSH that I would say a lot of people don't really know. That most people may not know exist. So port forwarding, basically SSH can serve as an arbitrary wrapper around pretty much any TCP traffic and create a secure way of accessing unencrypted or insecure services such as POP3, IMAP, HTTP. So if you actually wanted to access a website from your browser that was HTTP that was not secured, you could create an SSH port forward to it and with basically an SSH tunnel and access it securely, which I think is really cool. There's 3 different types of port forwarding. There's what's known as local port forwarding. So take this port on the SSH server and make it local to my client. So if again, all of this does require that you have SSH access to these servers. So if it's a web server, you have to be able to SSH into that server. So, and I'm about to go over why we would use this in a second. Remote. Take this port on my client and attach it to a remote server. So this is actually, if anyone here works in IT or something, I've never actually worked like in IT trying to like set up security policies like as an IT level, but I worked in security doing stuff similar to this. This remote port forwarding is enough to make you just want to just like not allow SSH at all. Because I can say I'm running like, and I actually used to do this when I was at my university. So when I was at university, I worked as a lab instructor and a student teacher, and I had a desktop in I wanted a Windows desktop, and I want to be able to RDP in and like do my grades and stuff. So I would actually port forward the remote port onto an SSH server that I had access to inside of the department that was public facing, and then I could connect in. So this says, let me take this port on my local machine and attach it to the remote server. And if that remote server is public, anybody can access that remote server. So this basically means that with remote port forwarding, you can make remote port forwarding and SSH, you can make any internal asset external if they have access to an external SSH server, which is terrifying. And if you know anything about SSH, you can send SSH traffic, you can tunnel SSH traffic inside of like any protocol. I've seen people do it inside of DNS. So, and like the only way to really like stop it is just to like block TCP at that point. Anyway, I digress. That was kind of a rant, but it's a really cool feature. But it could be used by people maliciously. And then dynamic, this is actually a really cool one. This essentially creates a SOCKS proxy on the SSH client, which basically allows you to proxy out any request that comes into the server straight into the network that the server can access. So you can create a proxy using SSH. What we're going to do is I'm just going to kind of only demo local port forwarding right now. And this is the code to do it. And where this is actually useful, and this was actually a lot more useful, I would say, I would not say like a long time ago, but like with the advent of certbot and the fact that as HTTP certificates are free and things like WordPress now have plugins that allow you to secure your sites immediately, like this was a lot more useful when that, or in this example was a lot more useful when that didn't really exist. Now that SSH certbots are completely like it's easy, and like you can set up SSH release I keep saying SSL HTTPS really simply, then this example kind of doesn't really hold a lot of weight anymore, but it's still really cool to demo. So if I go to port.egger.codes, this is an insecure website. This is my welcome to Nginx, but imagine I had, say, a WordPress site here, or I had a Django site here. I had something along those lines, but I didn't really, I wanted to be able to log into an admin panel or a CMS or something and change it. But this is HTTPS. If I log in, my credentials are going to be fed across the internet, and everyone will be able to see them. So I could do this locally if I just secure it. So if I use SSH again, SSH-L for local. And then the way the syntax of this code essentially is the port I want on my local machine to attach, the IP address or DNS name of the actual server, and the port on that server I want to connect to. So I want to take port 80, which is my HTTP port, on port.egger.codes, which is my server running my web server, and I want to put that on my local host 8080 and connect to it securely. And then you actually have to just actually SSH into it. So I'm going to SSH in as root at port.edgar.codes. And I run this. And I'm SSH'd in. Everything's fine. It doesn't really know anything yet. And then if I go back over here and I go to localhost port 8080, I can now see my welcome to Nginx site on my localhost running 8080, and I'm on localhost. Now, this is secure traffic. This is securely forwarded. Now, I could actually log into a WordPress admin or a Django admin or any of those things, and my credentials would be secure. So you can do that relatively straightforward. And it makes it a lot easier. I would always recommend just using HTTPS, but this could be used for anything like IMAP or POP3 if you're using like old old email services or anything at all that you want to be able to make sure it's a secure connection, you can SSH port forward to it. So one of the last things I'm going to talk about is an OpenSSH based VPN. So OpenSSH supports building generic tunnels that can pass all traffic and protocols, not just TCP. This is not supported by PuTTY. PuTTY very openly says that they will not do this. And so you can actually see that on their website. And I'll be honest, this isn't the greatest idea. Just because a tool can be used for something doesn't mean that it should be used for something. OpenSSH based VPNs have issues. When a TCP packet is lost, and just in general networking, when a TCP packet is lost, it's retransmits. OpenSSH is a TCP protocol. So wrapping TCP inside of TCP amplifies your packet reloss transmission. TCP-based VPNs collapse when they are overly congested. This is probably one of the most complicated things you can do with SSH. I don't recommend it. This is one of those things that's like, oh, this is fun to play with, and maybe if I need it very shortly, and it's a very small thing, and I don't want to spend the time setting up OpenVPN or WireGuard or any of those things. This is a way to do it, but I would not recommend doing this for like a long-term solution. This actually could be used, like, this has really interesting use cases, especially if, say, maybe your VPN goes down, but you still have public access to an SSH server in there. You could potentially use this to regain access to fix something if you're like you just SSH to actually use it. So yeah, this is one of the most advanced things I would say you could probably do with it. I'm not going to demo this today because it would take a long time to demo. But one of my resources that I'll talk to you about at the end actually will show you, like, there is a great chapter in the book about how to do this. So in my last talk, we actually talked about what would it be like to actually use a honeypot and do an SSH honeypot. And I actually set one up. So a honeypot, for those of you that don't know, is a server that is intentionally left open for attackers to exploit. Once the attackers are inside the server, they're dropped into an environment that looks like a normal server, but it's a decoy. Events on this machine are typically ignored. Commands actually don't get executed. Like commands like ls and stuff get executed, but actually like trying to bind ports or change configs. It's basically like I'm pretty sure it uses tempfs. And you're just given a temporary file system, and as soon as you log out, your session's deleted. You're not actually allowed to execute anything. It's a really cool thing to use, and you can kind of just see what's going on. So I use github.com/Cowrie, and here's the docs for how to do it. And let's pull up my little honeypot. I'm gonna log in because I used a non-standard port. I have to find it now. There it is. So we're in my honeypot. Sudo, I think, is one of the, yeah, we're just going to go into Cowrie, and then that's the log. So let's actually do an ls-lh, I think is for human readable, Cowrie var log Cowrie. Okay, so my log files are 8.6 megabytes of data, and I turned this server on yesterday. So as you can see, I'm actively getting attacked right now. This is my honeypot. So I can see connections coming in. I can see, man, there's a lot of them right now. They must be trying. So I wish let me see if I can slow some of this down. Is anybody actually running any commands? Doesn't look like anyone's actually running any command. Oh, look, nope. Someone's trying to echo some binary nops in there or something. I don't know what that is, but like they're trying to inject binary into it. So this server is actually being attacked right now. And yeah, so this is just if you're curious, stand up a little honeypot and see. But like I'm getting a lot of attacks, and like there's okay, what we got there, that was something interesting. Someone's trying to get a certain PHP page. I'll be honest, I'm reading this really quickly and fast, and it's kind of tough to actually see what's going on. But yeah, this is my active honeypot that is currently being attacked at this speed. Like this is the speed that people are actually trying to bang into the server. So set one up and go through and read it. It's actually pretty interesting. But this is just I did this as an example to show you that your SSH server is going to be attacked. Like you're always being attacked. So in security on the internet is very important, because you can see these are, I guarantee you, this is not people. These are botnets. These are all botnets that are currently, banging up against trying to get in, and some of them actually get in because, again, this is a botnet. I think it's got root and no password is the SSH in. So anybody, that was a good one. There we go. So this is I don't know what this is. This is some sort of binary where they're trying to actually inject like some sort of command into the machine, and trying to inject binary data and execute something on the server, and they're going to find out really quickly that it doesn't work. So this is my honeypot server. Because I mentioned it in the last talk, I wanted to make sure to show you, but this is mostly, again, just to show you this. Like this is the frequency at which I'm getting attacked, and this is a $5 droplet on DigitalOcean that hosts nothing. Like there's nothing important on here, and this is at the frequency at which I'm being treated very unnicely. So if you get bored, set one up. They're cool to watch. It's honestly pretty cool. So if you're ever like, well, why do I need security? I'm not going to get attacked. This is a server that does nothing, and it's getting attacked at breakneck speeds. So take care of yourself. That is, I think, all of the demos I have for today. So here's some resources. OpenSSH.com is a great place. A lot of the data from this presentation came from this book. Actually, the second edition of this book. This is the first edition, and I own the second edition in Kindle. SSH Mastery by Michael Warren Lucas. He is probably my favorite tech writer one of my favorite tech writers of all time. Also, the Google Authenticator stuff came out of the tutorial and this PAM Mastery book, which he also wrote. And as you can see, it's the FreeBSD Beastie and the Linux Penguin. It's one of my favorite books. Great books that I would highly recommend. So if you're looking to learn more and like do a lot more interesting things with SSH, definitely check out that book. Like SSH is honestly one of the most powerful tools that we have at our disposal. And I don't know how much y'all learned today, but like whenever I first bought that OpenSSH book, I think 3-4 years ago, if you actually go to my old YouTube channel, you'll see me doing presentations on it. When I first bought that book, I learned a lot. Like I never learned about I was right out of college, but I never learned about like port forwarding and stuff. And it's really cool. So I hope you learned something about SSH today. That's all the time I have for today. I'm going to spend the next 7 to however long until I'm told that I have to leave minutes answering the questions. I'm going to answer from top down. If you have any questions, go ahead and start putting them in the chat now. But I'm going to scroll all the way back up to the top, and I'm going to start answering the questions. So where are we at? Let's see. Hello from Ireland. Whole bunch of hellos. Got a couple people from Texas. Good to see you. Howdy. Can we assume the talk will be available later so as to avoid yes, all DigitalOcean Tech Talks are always available later. My slides will be available. They'll be on community. This talk will be uploaded back to YouTube. So 100%, you can always be assured that all DigitalOcean talks will be on. And if you want to take notes, hey, that's great. If you want to come back and watch later, it's always going to be there. Okay, so please, Abed, oh my gosh, I'm so bad at names. Parizar asks, please explain the best practice to SSH to Docker containers too. Okay. There's a lot of mixed feelings about Docker containers. Honestly, like if I ever need to actually get into a Docker container, I just exec in using Docker. In my mind, if you need a service that you need, Docker is meant, okay, stand back. Docker and like the containerization movement is meant around treating, the phrase is cattle, not kittens. I didn't touch my volume, but I am listening to Bohemian Rhapsody later. So cattle, not kittens, which means if the Docker container gets sick, it needs to be killed and start a new one. And in reality, what should be happening is your logs should be being forwarded out of the Docker container into, say, something like rsync or Splunk or some way to get the logs, or they should be mounted in a shared volume so you can examine what happened and then go from there. So SSHing into Docker containers typically is not something that people do. You normally exec into Docker containers using the Docker command. Running a Docker daemon in SSH strike that, reverse it. Running an SSH daemon in Docker would not be something I would recommend doing, and you don't really want to, like, in my opinion, it's not really something you would want to do. So in reality, use Docker exec, not SSH. If you have to SSH into it, you probably could, but that kind of defeats the purpose. At that point, you should just be running a server or a droplet or some sort of VPS if you want to be able to SSH into them. Or using Docker exec, but like the whole point of Docker containers is they do only what they need to do, and they need to run with little overhead, and they only have the libraries installed that they need. So creating a large Docker is creating a very inefficient VM is what you're doing, because you're going to have to install the SSH daemon. You're going to have to do all of those, like all of that configuration. I'm not touching the volume controls. My computer has ghosts in it. So I highly recommend not doing that. OpenBSD rocks. Yes, it does. How is encryption different from crypto? So crypto is a word that, this is said by Ashish. Crypto is a word that is it's thrown out in two different ways. So crypto before like 2011 was cryptography, and cryptography is really the study of secrets. Encryption is part of cryptography, but cryptography is actually a lot of math. So encryption, different from crypto, encryption is part of cryptography. Now, if you're saying like crypto, like cryptocurrency, I finally get to use this metaphor. Crypto is to cryptography, Crypto is to cryptography as Java is to JavaScript. Like cryptocurrency has nothing to do, like, I mean, it uses encryption algorithms, and that's kind of where the name came from, but they don't really have much in common other than that. So what are the various uses of cryptography? Oh, that's a big, basically creating and securing the internet and creating and securing data. That's what it is. And that is a bigger topic for a much bigger time. Yes, I think I responded to that earlier. Can I incorporate two-factor auth as a Google Authenticator? I did. Can you use SSH key and a username pass combo? I don't know how to do it off the top of my head, but PAM is very, like, so if there's not something that immediately can do it, you can totally probably write your own PAM module to do it. Do you have a password on your keys that are used for automation? Ooh, okay. So that's a good question. Rob Mitchell asks that question. Do you have a password on your keys that are used for automation? Sorry. Okay. So I'm trying to think back to when we ran a Jenkins server, if we had a passphrase on it. I think the answer was yes, because I think Jenkins allowed it. However, if you could log into the Jenkins server, I think the way that Jenkins worked back then is you could just copy out the password and you'd get it. So there is a big debate on whether or not you have passwords for keys that are like automated keys and stuff. You can, but that kind of, again, that really does like inhibit you, and it makes life a little bit more difficult. If you're not going to use a password on your keys, then they need to be rotated very frequently. There needs to be an automated process, and you need to be rotating those keys every 60 days, maybe. Come up with your own policy on that one. That was a random number I pulled out of thin air. But if you're not going to be using automation on those keys or passphrases on those keys, then you need to be rotating them. But if you are going to use them, then you could probably do it. But again, if it depends on how secure is the thing that you're sending the password through. If you're doing it through a bash script, and then it's in bash. If it's in your terminal, and now your console has it, and now you have to, like, maybe you export the variable, now it lives in memory, and now it's there, so it leaks. Something's going to leak the credentials, unless you're using something like Vault, on the other hand, where Vault has access to get those. And maybe at that point you might be able to. That actually be a really fun thing to talk about, would be like doing automation SSH keys and using Vault to store the passphrases. I might actually maybe write a tutorial on that. That would be really fun. So thank you very much for that question. It's a great question. Does spoofing only happen via DNS resolution? Spoofing happens through everything. You can spoof man-in-the-middle attacks. You can, like, there's man in the middle. There's DNS resolution. There's DNS, there's all sorts of spoofing attacks. IP spoofing, MAC address spoofing. There's so much different types of spoofing. You have to be aware of that. Do you recommend SSH FP and DNS to have fingerprints? Are there ways to use those DNS fingerprints to automatically verify servers? Oh, it's a great question, Armin. I actually don't know what SSHFP is. I'll be honest. I don't know what that is. To have fingerprints, are there way to use DNS fingerprints automatically to verify servers? I don't know. There might be. That sounds like a really cool topic. I'd have to look into that. I'm sorry I can't answer that question right now. I know like this much about DNSSEC, and I don't know if it does that. So that's a great question. I'm sorry I don't have an answer. I will. The magic voice in the sky that the magic voice in the sky that doesn't come out and talk to me anymore. She chats me. We'll have like a list of all these questions in a Google Doc, and then we'll provide the answers to it. I'll actually look that up and I'll get the answer to you later. Oh, and the magic voice reminded me, crypto book that I like. And is it on my shelf right now? It normally is. It's somewhere. Oh, poop. It's probably up there, but I don't feel like getting out of my chair to go like hunt through it, because it's not where it should be. So that means it's somewhere else. The Code Book by Simon Singh is a great book that talks about the history of cryptography, starting with like Caesar and Queen Elizabeth and like Anne Boleyn, and how like cryptography, like kind of like cryptography and the study of secrets and stuff, brought down Anne Boleyn and all this. So it's a great book. It's called The Code Book, COD, just like Code Book, by Simon Singh, SINGH. Excuse me. Amazing book if you're interested in the history of cryptography. Anyways, I was curious which one serves the company better, using an open VPN for users to connect or using a server. Oh, VPN. SSH server for tunneling through. Again, like as I mentioned, that like TCP and TCP is just, and it wasn't like, just because SSH can do it doesn't mean it was designed to do it. It's kind of like flexing, like showing the flexibility of the protocol. But I would not recommend it. Use a real VPN. I would not recommend using tunneling. Is key forwarding available by default or needs to be activated? The SSH agent, you actually have to use the SSH agent command. So if I go back to, you actually have to run this SSH agent, dang it, command right here in the second big bullet right here. So that turns it on your machine, and then you can use SSH-A, and then that will forward the SSH agent. No mention of proxy jump. I actually don't know what that is. Can I recommend you a few VPN programs? Unless that's like -o proxy commands. In which case, I know a little bit about that, but not enough to speak about it right now. Again, I can Google that. I can get you an answer later. VPN programs, WireGuard and OpenVPN are the ones that I hear all the time. A lot of people really like them. Anything about using YubiKey? I actually don't know. I have no idea how Zscalers work. Can I integrate it with Azure AD? Probably. I've seen Active Directory integrated with SSH before. How to do it with Azure AD, I don't know, but I'm pretty sure it's possible. YubiKey Google can't install TLS cert through a WordPress plugin. I could have swore there was an OpenSSH a certbot plugin that lets me just set up SSL on my WordPress site. Again, I don't use WordPress that often. I thought I did it once. I could be wrong. But I would definitely say go to the plugin store and search for certbot and see if it exists. I'm pretty sure it does. I could be wrong. How do you secure a CalDev server that cannot have an HTTP password but has an internal login only? You could hide it on a subnet that needs a VPN. SSH with tunneling. SSH with tunneling would probably work there. I don't know enough about how HTTP passwords, like an htaccess file. Yeah. I would SSH tunnel to that, to be honest. The command line that checked the cool thing in the attack report. I just use tail-f to follow the log file. So and the Cowrie server has a log, and it just logs everything, and I just was following it. So tail like gets the end of the end of a file, kind of like head gets the beginning of the file, tail gets the end, and then you can use tail-f at the end that will follow the file, and then it just kind of leaves it open, and then as logs come in, you'll see them. It's a really cool tool. What do you think about OpenSSH certificates? Okay, so in the new book of the OpenSSH Mastery that I recommended in my resources section, there's actually a whole chapter on certificates and certificate authorities, and I actually haven't had time to read it yet. So when I read it, I'll answer that question, but I haven't gotten a chance around to that yet. Yeah. Have any recommendations for analyze attack in the log file? Not really. You just kind of look at it and you see what's going on. Like there's a lot of like malware detection and like things like that. I'm not a pen tester, so I'm not really one that's aware of it. I just thought it was nifty to see how many people were trying to get into my server. Could you please? Oh, I'm sorry. I wasn't listening. Okay. I unfortunately am out of time because I was getting and I didn't need that. Yes, thank you for the questions. We're done. Sorry for going over a little bit. And we're good. For the questions that I did not get to, I will get you an answer to them, and we will send those out. They'll be on the Tech Talk page. So if you go to do.co/tutorials and you just search for and you look for Tech Talks and you just search for utilizing SSH or you'll see it and you'll be able to access them. Thank you everyone for attending, and I hope to see you next time. I don't know what I'm doing yet, but it'll be a fun one, I promise. See y'all later.